Welcome to dear students. Here we are going to learn the organometallic chemistry. This is the course of CHG-290. Last time we learned about what is the difference between homogeneous catalysis and the heterogeneous catalysis. Okay, and from that we already start to learn the examples of different homogeneous catalysis and their cycle. Today we are going to learn the next catalyst, that is called as a Wilkinson catalyst. This is mostly useful for the hydrogenation of the alkene compound, and this is the homogeneous catalyst. This is what? This is the homogeneous catalyst. This is okay. Here let me start. What is a homogeneous catalyst? That means the reactant and the catalyst both are in the same phase. That is called as a homogeneous catalyst. Here, what is the Wilkinson catalyst? Wilkinson catalyst is the RHPPH3Cl. This is called as a Wilkinson catalyst. Always ask in the net set examination and your MCQ, what is the Wilkinson catalyst? What is the formula for the Wilkinson catalyst? The formula is what? This is the Wilkinson catalyst. Okay, this is RHPPH3 thrice and Cl. This is called as a Wilkinson catalyst. Okay, and this catalyst, which is mostly useful for what? Hydrogenation of the alkene. These are very important for your MCQs. Last time we learned hydroformylation reaction. You must have to remember what is the hydroformylation reaction and which catalyst used for this. Okay, today we are going to learn the Wilkinson catalyst, that is RHPPH3 thrice Cl. Okay, and this is catalyst is called as a Wilkinson catalyst, and this is useful for the hydrogenation of the alkene. So let's start our topic, that is Wilkinson catalyst. Here what happened? First of all, this is the Wilkinson catalyst, that is RHPPH3Cl. This catalyst which is dissolved in the solvent. Then what happened? This replace the P1PPH3. Here you can see this, there is a removal of 1PPH3 and the solvent, this solvent which is added to this position. This, the coordination number of this catalyst is what? 4. Okay, then after that it shows oxidative addition reaction. We already discussed about the oxidative addition. What is oxidative addition reaction? This, in oxidative addition reaction, what happened? The coordination number is increased by 2. That means the coordination number is changes to 6. Okay, second is what? Here in the oxidative addition, the one molecule which is get breaking. Here there is a H2 molecule. This H2 HH going to break, and this is separately added to the molecule like this manner. Yes, here there is a hydrogen and this is another hydrogen this time, and here the oxidation number of this catalyst is going to increase. Here there is a 2 oxidation number, then after the addition of these 2 it goes to plus 4. Okay, this is called as a oxidative addition reaction. You can see here, this is the coordination number of this compound is 4. After the addition of H2 on the oxidative addition, what happened? These 2 hydrogen added to this position, and here their coordination number is increased by 2, and here it becomes what? 6. Okay, then after that what happened? There is addition of alkene. This double bond is, it is nothing but what? alkene, that is, this is the CH2 double bond CH2 molecule. Okay, that is called as ethylene. After addition of this ethylene added to this rhodium like this manner. This shows what? Pi bonding. This is not the sigma bonding. This shows the pi bonding. Okay. After the bonding of these, what happened? Then it shows the migratory insertion. It shows what? Migratory insertion. This is what? 1,2 migratory insertion. This is what? 1,2 migratory insertion. Why? Because we already discussed this. What is the migratory insertion and their types? If you see this lecture, then you can understand how this migration will happen. Okay. Here what happened? By breaking this bond, this one CH2 which is directly attached, this is carbon number 1 and this is carbon number 2. This one CH2 is directly bonded to the rhodium. Then the same time, what happened? This hydrogen which is migrated or inserted into this CH2 compound, and it becomes what? CH2 CH3. This hydrogen is added to carbon number 2. Okay, that's why it is called as a 1,2 migratory insertion. Okay, like this. There is the formation of CH2. This is already CH2 is there, and here this becomes CH2H. That means this hydrogen is bonded to this position. Okay, that is called as a migratory insertion. What happened in this cycle? This is very simple. Hydrogenation of alkene is there. Here we use the Wilkinson catalyst. In this catalyst, first of all, the oxidative addition takes place. Oxidative addition of hydrogen takes place. Hydrogen is added to this. Then after that, alkene is added to like this manner. There, first of all, there is a formation of pi bond with that of the RHS takes place. Then after the 1,2 migratory insertion, this form a sigma bond with that of the rhodium metal. Okay, then after that what happened? We want to remove this molecule. Why? Because here there is a hydrogenation of alkene. That means there is an addition of alkene to the alkene. Okay, and that's why what happened here? There is an addition of alkene takes place over here. That means there this double bond get converted to what? The single bond. Then we has to obtain our product, and that means we has to break this bond. And for this, what is the next reaction? We already learned, that is the reductive elimination. What is the reductive elimination? Opposite to the oxidative addition. That means here coordination number is 6. It get changes to coordination number 4. Here there is a coordination number is what? 6. Okay. Then at the same time there is a breaking of 2 bonds takes place. There is a hydrogen is breaking over here, and here there is a carbon and metal bond is going to break, and by breaking these 2 bonds there is a formation of the one molecule. That means here by breaking this CH2 at this position, this hydrogen is added to this. Okay, and then what happened? There is a formation of H. This is the CH2, and here also the CH2. That means alkene get changes to alkane. This is what? Ethane. That means this is the alkane, and this is what? Ethene. This is ethene. By the removal of this our product, this is ethane is our product. By removal of this product, we get the original catalyst. That is what? By removing this, what we get over here? This is RHPPH2Cl and the solvent. We get our original catalyst, and this cycle is continue and the continue. Okay. This is our product, and this is the simple hydrogenation of alkene by using the Wilkinson catalyst. And that's why here this catalyst which doesn't participate in the reaction, but it increase the rate of reaction. Okay, why this doesn't participate in the reaction? Because here at the end we get our original catalyst. Okay, and here this original catalyst we used several times. That's why in this type of reaction we require very minimum amount of the catalyst. Okay, and this catalyst is helpful for the production of the number of higher quantity of the products. Okay, this is about what? Wilkinson catalyst useful for the hydrogenation of alkene. Next reaction let we learn, that is a hydroformylation process. Okay, in this hydroformylation process, what we use over here? We use the catalyst, that is CO2, that is cobalt, and CO8. Okay, this is the catalyst useful for the hydroformylation reaction. What is a hydroformylation reaction? In this reaction, the alkene get converted to the formyl group, that is what, aldehydic compound, that is called as a hydroformylation reaction. For this hydroformylation reaction, we use the catalyst, that is what, CO2COH. This is very important for the MCQs. In the hydroformylation reaction, dash dash catalyst is used, and that time you give the Wilkinson catalyst, Wacker, and the another catalyst also. Okay, you has to know which catalyst useful for the which process. Okay, for the hydroformylation we use which catalyst? CO2COH. So let's start this cycle. This CO2COH, by the addition of the H2, this shows the oxidative addition reaction, and by breaking this bond, this dimeric compound get converted to the monomeric compound. That means we get the 2 moles of HCO4. Okay, we get here the 2 moles of this compound. We require only 1 mole, that's why here they gives us the only 1 mole. Okay, here we get here the 2 moles of HCO4. This CO is what? Cobalt, and this CO is carbonyl. Okay, okay. Next, what happened? There is a removal of 1 COS takes place over here. Okay, by removing of these, there is a formation of what? HCOCO3. Why we remove this carbonyl? Because this is very stable compound. This is very stable compound. For the activate the reaction, we must have to unstable catalyst. That's why by converting stable compound to the unstable, we remove 1 carbonyl. Okay, and then there is a formation of HCOCO3. After that, there is the addition of what? Alkyl compounds takes place over here. By the addition of this always remember that this alkyl compound, first of all, always bind to like this position. That means this metal which is bonded to the pi bond. Okay, pi bonded is takes place at the first time whenever the alkene is attached to the metal. Okay, then we get this type of the compound. Then after that, what happened? Here these get converted to the this pi bond get converted to sigma bond. How this possible? By the 1,2 migratory insertion. 1,2 migratory insertion. Okay, then what happened? This is a 1 carbon number 1, this is carbon number 2. Then what happened? This cobalt, which is directly bonded to this carbon, and this hydrogen is attached to this carbon number 2. Then we get here CH2R. Okay, first in this case there is a CHR is there, and after that here this hydrogen is attached to here, that it becomes CH2R. That means this hydrogen is attached to the carbon number 2. That's why it is called as a 1,2 migratory insertion. Okay, here this is another possibility is also there. This is, they shown us this type of another possibility. If this is carbon number 1 and this is carbon number 2, then what will happen here? Okay, let me see here. If this cobalt, here there is a hydrogen, and here this is our compound R. Okay, and this is what? CH2. It has a 2 possibility of the migratory insertion. In the first case, what happened? This is carbon number 1 and this is carbon number 2. In what happened here? This carbon number 1 is directly attached to this metal, and the same time this hydrogen attached to the carbon number 2, and then we get what? CO. This is CH2. Okay, I am writing this. See, this is CH2, and here this is CH and R. Okay, and this hydrogen attached to here, that it becomes what? CH2. This is first possibility of the formation of this compound. Second possibility is what? Here second possibility is what? This is the carbon number 1 and this is carbon number 2. Then what happened? This carbon number 1 is attached to this metal, and here this hydrogen is attached to this carbon. Then what happened? This carbon is directly, cobalt is directly attached to this CHR group, and here This is already CH2 and this hydrogen attached to this carbon. That becomes what? CH3. Okay, that means here we get the two types of the product, 1 and the 2. Okay, they shown us these two type of product. This is 1. Okay, this is one type of product, and this is what? Second type of product. You can follow this also, and this I'm following this first, and here the so what assignment for you, you have to following this another route and prepare the product. Okay. Okay, then here let we see the first type of the product. We get like this after the 1,2 migratory insertion. Then after that we add the carbonyl, and here there is a this carbonyl is directly inserted to this compound. Okay, then that means what happened over here, this is our product. Okay, this is our product, that is like this. This is CH2 and this is CH2R. Okay, and here then there is an addition of carbonyls takes place. Already here there are how many carbonyls there? CO3 is there. Okay, then after that what happened? This carbonyl, this is CO3, and here this carbonyl is attached to here, and here this is our CH2 CH2R. Then next time what happened? This carbonyl inserted to this compound, and it becomes what? CO3. It originally like this. This is cobalt, and here this is the carbonyl inserted in between cobalt and the alkane compound. That is, it becomes what? C2H4 are like this manner. Okay. Okay, here like this manner. This is carbonyl which is attached to here. That time this carbonyl is inserted. This is a carbonyl insertion to this, and here this become CO CH2 CH2R compound. After that there is a oxidative addition is takes place. Oxidative addition is takes place over here. This 2 hydrogen added to here, and then next step is what? You know very well. There is a reductive elimination. This is reductive elimination reaction is takes place. By breaking this bond, there is a elimination of these 2 bond, and there is a formation of this aldehyde. Okay, this is a CHCO CH2 CHR. Okay, and here we get our original compound, that is CHCOCO3. Okay, this is our original catalyst. Okay, here you must know in the process what is the hydroformylation, and which catalyst used for the hydroformylation. First case, for the hydroformylation you can directly write this compound also, HCOCO3. Okay, next is what? Hydroformylation is a process which is useful for the conversion of alkene to aldehyde. You must know the conversion of alkene to aldehyde. Okay, here alkene is what? Double bonded, and here it get converted to the CHO compound. And if you know this, then according to that you can add the different processes which is used in the catalytic reaction, that is 1,2 migratory insertion and the oxidative addition and the reductive elimination. Okay, for this you don't have to mug up this process. You have to understand this process, how and why we use these different processes. Okay, for this you must have to know which catalyst used for the reaction and what we have to prepare from a reactant. Okay, then only you can write down the different cycle. In the hydrogenation process, here we has to only convert alkene into the what? Alkane. That's why we has to only add only the hydrogen. But in this process we has to convert alkene into the aldehyde. That means we must have to convert first of all alkene into the alkane, and then we have to insert the carbonyl into that, and then oxidative addition is takes place. Okay, this is the hydroformylation process. Thank you very much for watching this lecture. You see this lecture and comment on the comment box. Okay, this is your what presenting. So thank you very much.